Page 323, I want to give you this thought. What if you have a square root, number 44, the square root of 7 times the square root of 5. How do you do the square root of 7 times the square root of 5? Well, we go from something incredibly difficult to something that's obviously easy. What would you do with that? Square root of 35, right? Boy, that was tough. Now, but it's not going to stay like that, is it? You're probably waiting for the other shoe to fall. And it falls in problem number 48. Skip on down to number 48 where it says the square root of 35 times the square root of 55. Okay? The square root of 35 times the square root of 55. Now, if you can use a calculator on that, can't you? And what you can do is make the square root of 35 times 55, and you'll end up with some big, huge number, and now how are you going to simplify it? So I got a better idea. Instead of multiplying it out and getting a big number, let's break the numbers down. In other words, take the number 35, and what is 35? 7 times 5. Now take the number 55, and what is 55? 5 times 11. Now, do you see a perfect square that's in this number? See, instead of having one big number that's in a multiplied form, we've got a factored form, and what would be the perfect square? 5 times 5. Okay? So in other words, when you've got 5 times 5, that would be a perfect square. When you've got a pair of numbers, that pair is a square. Okay? So in other words, now let's break that up and make two separate square roots out of it. The square root of 5 times 5 would be the square root of 25. And what's the leftover number? 77. Okay? These two, 7 times 11 is 77. 5 times 5 is 25. Now what's the simplified answer? The square root of 25 is 5, and the square root of 77 is the answer. 5 times the square root of 77. Any question on that? All right?
I saw that long shelf over where you had that 7 times 5 and the 5 times 11.
Okay.
I thought you wanted to multiply the 35 times the 55.
Right, and get one big number. Right?
Yeah, I saw that long
Yeah.
arm on there.
And then what are you going to do? But see, if you get a big number there, you don't know what to do with it. So it's much better to break the numbers down. Okay? I'd like to look at another problem here that I know will cause you a problem. Number 52. Look at number 52 next. Number 52, still on page 323. And it says the square root of 85 times the square root of 20. Okay? Now again, we make one square root, one big happy square root, and let's break down the 85. What number goes into 85?
17.
5 times 17, right? And then what about 20? 5 times 4, all right? 5 times 4. Now remember what we're doing here. We're looking for perfect squares. Looking for perfect squares. And if you ain't got no pair, then you ain't got no square, right? So 5 times 5, that's a perfect square, isn't it? So circle that. Now what a lot of folks forget about this, they get the pair of 5s, they say that's a square. The pair is a square. They got that down. But look again. Do you see any more squares in that?
4.
The 4 is a square all by itself, right? So that is a square. That 4 represents a pair of 2s, right? All right? So now, what do we have? We got to, now, you don't have to actually, well, let me go ahead and make one more step. Make two square roots. And what goes in the first square root? You got 5 times 5, that's going to be 25 times 4. And then what's left over would be 17. Okay? Now, then the answer would be, the square root of 25 is 5 times 2, let me do that in yellow, 5 times 2, and then left over would be square root of 17. What's the final answer then? 10 square root of 17. Let me do that in yellow. 10 square root of 17. Any questions on that?
You don't have to master that 4 until you get down to the second to last problem.
No.
Oh, you really don't have to.
In fact, you really don't have to do 5 times 5, do you? You could just, you could skip all of this. Let me show you the shortcut now.
Okay.
When you see the pair of 5s, what do you get for an answer? 5. When you see the 4 is the square, what's the square root of 4? 2. 5 times 2. And then everything that's left stays inside the radical, which would be the square root of 17. And then what's your answer? 10 times the square root of 17. Okay? Any questions on that? All right? That's all for this assignment. And now I'm going to begin again to show you some problems in a few minutes, beginning on page 323 and continuing over to page 328. Okay, so we'll take a break and let you do a problem. Okay, continuing on the bottom of page 323, I'd like to do a problem number 54, which says 2 square root of 6 times 5 square root of 10. Now in this problem you're multiplying a number times the square root times another number times the square root. This makes a total of 4 different numbers that are being multiplied together. There's 2 times the square root of 6. There's 5 times the square root of 10, and the product of all 4 of those numbers. Now when you multiply 4 numbers together, you can multiply them in any order that you want, right? By the commutative and associative properties. In other words, I can multiply the 2 times 5 together if it's convenient for me to do that, and it is, isn't it? So what's 2 times 5? 2 times 5 would be 10. And then we've got a square root of these numbers left over. 6 times 10 would be 60. So in other words, what we do when we multiply numbers and square roots, if the numbers are outside the radical, they are coefficients, and we keep them outside the radical. And the numbers that are inside the radical are called radicands, and we keep those numbers together as radicand in the answer. So if the number is outside, it stays outside. If the number is inside, it stays inside. Now, are we satisfied with this answer, or is there something else we can do with it? I think we can simplify that, can't we? The square root of 60 could be broken down into what square root times what? What perfect square divides into 60? 4. Start small, like 4. Okay? 4 times, now what's the other number? How do we get that other number? You have to take 60 and divide it by 4, which would give you 15 for the other number. And we still got a 10 out in front, okay? A 10 coefficient. Now, what's the answer going to be? 10. Now, the square root of 4 is 2. So we put down 2, okay? And then times the square root of 15. Now, don't put the square root of 2. If you take the square root of 4, it's 2. Put 2, not the square root of 2. And then you can multiply. The 10 times 2 would be 20. So my final answer is 20 times the square root of 15. 20 times the square root of 15. Okay, any questions on that? Okay. Now let's take a look at the next page. Number 56 I'd like to look at. And I'll be just working through a few miscellaneous problems through the rest of this section. Number 56, it says 5 square root of 85 times the square root, times 3 square root of 51. So what 2 numbers would you multiply together first here? Remember, the coefficient times the coefficient, which would be 15. All right, that takes care of the 5 and the 3 that are outside. And then we'll put the square root, and inside the square root we'd have 85 times 51. You could do that with a calculator if you wanted to. What do you get?
4335.
4335. 4335. Now, is that a good idea? Because now you've got to simplify the square root of 4,335. Now, how many people want to simplify a big number like that? And I'll tell you what, if you start trying to simplify it, you'll have a tough time finding a perfect square. So instead of doing that, what's the other possibility? Instead of multiplying these numbers out, let's take the 85 and break it down. What's 85?
17 and 5.
Okay, 5 goes into 85. That's the first, the most obvious thing. 5 goes into 85. And then take the calculator and say 85 divided by 5 is 17. Okay? And then what number goes into 51? Probably 3. Okay, so we'll take that 3 and 3 times 17. Okay? Now, you've got a pair of 17s. Remember, we're looking for perfect squares, so we're looking for pairs of numbers. So the 17 times 17, you don't have to actually multiply 17 times 17. Just recognize you've got a pair, and then the square root of 17 squared would be 17. Okay? So the square root of 17 squared, in other words, if you need to write a middle step, make it the square root of 17 squared, and then times the square root of the leftover numbers, which would be 3 times 5, which is 15. So this 3, this 5 is where I get the 15, and I've got a 15 for the coefficient. 15 in front of the whole problem. Now, final answer then. No, not final answer. The answer I have, next step would be 15 times, what, 17? Square root of 17 squared is 17. And then it'll be the square root of 15. And one last step, with a calculator handy.
255.
255, okay? 255 times the square root of 15. Okay? Any questions on that? Okay, that was number 56. If you look down next to number 66, let's take a look at number 66. And here you're going to have to use the distributive property. It says 6 times the square root of 5, and then times, parenthesis, 4 square root of 2, minus 7 square root of 3. Looks like a horrible problem. But think of this as being the distributive property, where I'm going to have to take the 6 square root of 5 times the 4 square root of 2. Do this first. Multiply this times this. And what would you multiply together first?
6 times 4.
6 times 4 would be 24. And then the square root of 5 times 2 would be
Square root of 10.
square root of 10. So the 24 is outside the radical, and the 5 times 2, because the 5 and the 2 are inside the radical, the 10 stays inside the radical, right? And then let's take the 5 square root of 7 times the negative 7 square root of 3. So first of all, it'll be a positive times a negative, which would be a negative. And we'll multiply the coefficients together first. The 7 times 6. 6 times 7 would be 42. And then inside the radical, you'll have the square root of 15. Okay? And that's all you do. Because you can't simplify the square root of 10, and you can't simplify the square root of 15, and they're not like, so you can't combine them together. End of problem, right? Okay, now, you think they're all going to stay like that?
Hopefully.
You hope. But there's no chance. So when you turn the page, I'd like you to look at number 73. Number 73, I especially want you to see, because I've got an error in it. There's an error in the way number 73 is laid out. So I want to be sure to tell you about this. Number 73, we're now on page 325, cruising along, 8 square root of 10, and that's going to be times 2 square root of 6 minus 3 square root of 2. Now I don't know, this book must have been written for for college algebra students or something, because it's got a blank line, and then it's got an answer. And before you can get to that answer, it's going to take most people in this course 2 steps in order to get to that step. So put an extra blank line in there before you get to the next step. In other words, here's what I want you to do. I want you to first do the 8 square root of 10 times 2 square root of 6. And what would that be? Just go ahead and multiply that out.
Okay,
8 times 2, 16.
Square root of 60.
Square root of 60. Okay? And then the next part is going to be minus 24 square root of 20. Okay? That's the first step. Now, here's what I want you to add. I want you to add an extra step in there before you get to the step that's given. You see, there's a step where the answer is given to it looks like the third step is given, but it should be the push down to the fourth step. I hope you understand what I mean by that. Now, I want to take this 60 and break it down. Can you break down the 60? Square root,
4 and 15.
4 times 15, and this would be
4 times 5.
4 times 5. That is square root of 4 times the square root of 5. Okay? And now you'll be ready to bring down what? 16. Bring down the 16. And the square root of 4 would be 2. The square root of 4 is 2. Remember how we did this on the other page? And then the square root of 15 is the square root of 15. And then we've got a minus sign. And we've got a 24 coming down. The 24 comes down. And the square root of 4 would be 2. And the square root of 5 is the square root of 5. So we just leave that as the square root of 5. Okay? Now that's the step that's given to you. But really, it took 2 steps to get there, didn't it? It really took 2 steps. So I should have had some extra blanks in there to help you out. Now you can come up with a final answer. What's the final answer for this thing?
32.
32.
Square root of 15.
Square root of 15. Minus
48.
48. 24 times 2 is 48. Square root of 5. Like that. And they're not like radicals, so they can't be combined. Okay? Any questions on that? All right? Now, I think I'd like to look over to a FOIL problem. The FOIL problems are introduced rather gradually, but I'd like to start you off with number 80 as a nice even number to begin. Still on page 325, number 80. And it says 3 plus the square root of 5 times 2 plus the square root of 7. And remember, this is a product of binomials. This is a binomial times a binomial. Remember back in section 2, we learned a FOIL. So what we're going to have to do here is take the first times the first, which would be 6. All right, the F part is going to be 6. Next, we'll do the outer times outer, right, which would be? Now, be careful. Be careful. This 3 is outside the radical, and this 7 is inside the radicals. So what we have to do is take 3 times the square root of 7. Now, what is 3 times the square root of 7?
3 square root of 7.
3 times the square root of 7. Now, that was tricky, wasn't it? All right? So we'll have to put plus 3 times the square root of 7. In other words, anything you try to do to that is probably going to be wrong. 3 times the square root of 7 is just 3 times the square root of 7. Here comes another one. What's the inner times inner?
2
Well,
square
what
root
we
of
have to do is do 2 times the square root of 5, or the square root of 5 times 2, which is going to be plus 2 square root of 5. Okay? And then after we do that, then we go to the last times last, which would be square root of 5 times the square root of 7, which would be plus the square root of 35. Again, nothing combines together. All the radicals are different. Nothing simplifies. And how long do you think the problems are going to stay like that? Again, not very long. Eventually, we're going to get to some problems where you have to do simplification and the numbers get more complicated. Okay? Yes?
Yeah, it just seems to me like it shouldn't matter what number is under the radical. When you multiply two radicals, you should remove the sign.
A radical times a radical is a radical. Now, if you said a radical 7 times a radical 5, that is radical 35. Now, if you said a radical 7 times a radical 7, that would be the radical 49, which is 7. So the radical 7 times radical 7 does remove the radical sign. Okay? A radical 7 times radical 7 is 7. If you wanted to, you could put the square root of 49, and then that is 7. Or you could go directly to the answer and put 7. Now, the mistake a lot of people make, and we'll see this in just a minute, the square root of 7 times the square root of 7, a lot of people put the square root of 7, which is wrong. The square root of 7 is wrong. So don't put the square root of 7. Okay? All right, now, let's move on to a more challenging problem. One where the numbers are harder to work with, and I'd like to look at number 89 for a sample of that. Number 89, and it says 4 square root of 3 plus 2 square root of 2 times 4 square root of 3 minus 2 square root of 2. Okay? All right, so we're going to FOIL, right? And we'll take the first times first. Now be careful. Now we got to do this times this. So how do we do? We did that a minute ago, didn't we? You multiply the numbers that are outside, and keep them outside. And you multiply the numbers that are inside and keep them inside, right? So what are we going to have on the outside here?
16.
4 times 4 would be 16, okay? And then the radical 3 times radical 3 is
Radical 9.
radical 9. Or if you want to take a shortcut, you can put 3. Because everybody knows radical 9 is 3. But for the first problem here, I'm going to put radical 9. Don't put radical 3. If you put radical 3, you're dead in the water. Don't put radical 3. Radical 9 or 3. Plain 3. Now that's the first times first. Now the outer times outer. Outer times outer. A positive times a negative would be a negative. 4 times 2 is 8. Radical numbers together now would be radical 6, right? 3 times 2 is radical 6. And then the inner times inner would be 2 times 4, which is, now by the way, what sign? Positive times positive would be positive. 8, radical 6. You know something about that? Negative 8 radical 6, positive 8 radical 6 subtracts out, doesn't it? Sometimes that happens. You know, sometimes nice things happen, sometimes ugly things happen. You never know in a math problem. But this is going to subtract out, isn't it? This and this. Now let me finish up. Last times last. The last times last. Now it's a positive times a negative, which would be negative. 2 times 2 is 4. Radical 4. Okay? Now what? 16 times 3. Okay? 16 times 3. All of this is subtracted out. Then we have down there minus 4 times 2. Radical 4 would be 2. Now, radical 4 is 2, no radical. Remember, you've got to get practice at this. And by the way, the test is not a good place to practice these problems. Get the practice on the homework, because you've got to know whether to put the square root of 9, the square root of 3, or 3. You've got to know the difference in this. So the square root of 4 is 2, no square root signs. Okay? Now what? 16 times 3 would be 48. And then minus 8. 48 minus 8, which would be 40. Boy, that's the nicest answer we've had in a long time, isn't it? Just an answer of 40, imagine that. Okay, now on the next page, things are not always so friendly. I'd like to do two problems and then we're finished. Number 90 and number 96. I think that will be enough for the explanation purposes here. And then it'll be important for you to take some time to practice these yourself. Remember, this doesn't belong to you until you do the problem yourself. It's nice to watch somebody do it, but there's nothing like doing it yourself to know you understand this. No, I don't want to do number 90. Number 90. Yeah, I'll do number 90. Number 90. It has 5 square root of 2 minus 2 square root of 6 times 5 square root of 3 minus 2 square root of 5. Okay? So what I want to do here is multiply the first times first. And the first times first would give you 5 times 5 is 25 square root of 6. Okay? The outer times outer would be negative 10. Is that right? Negative 10 times the square root of 10. Okay, 5. The 5 times 2 outside the radical stays outside the radical. The 2 that's inside the radical times the 5 that's inside the radical becomes 10 inside the radical. 10. Right. Now, inner times inner. Negative times positive is negative. 5 times 2 is 10. Square root of 18. Okay? And then the last times last times last, a negative times a negative is positive.
4.
4. 2 times 2 is 4. Square root of 30. Okay, now it looks like we're finished. Or are we? There's one thing that needs to be done in this. The square root of 6 doesn't simplify because that's just 3 times 2. The square root of 10 doesn't simplify because that's just 5 times 2. What about 18?
2 times 9.
9. We need to have a perfect square of 9. The square root of 9 times the square root of 2. So that would give you a total of minus 10 times what? 3? 10 times 3? Square root of 2. For that one term. That's the only term that simplifies, but we still have to simplify it. And now bring down the rest of the problem and you'll have 25 square root of 6 minus 10 square root of 10 and then plus, and this 30. You can't simplify this square root of 30 either, so that's going to be 4 square root of 30. And now the final answer is 25 radical 6 minus 10 radical 10 minus 30 radical 2 plus 4 radical 30. And nothing there combines or simplifies. Okay? Any question on that? Okay? I got one more problem I'd like to do with you. One more problem, and that is a quantity squared. I'd like to look at number 96. Number 96, it says 5 square root of 2 minus 2 square root of 3, the quantity squared. Now what do we mean by quantity squared? Quantity times itself, right? So let me write that as a quantity times itself. It would be 5 square root of 2 minus 2 square root of 3 times 5 square root of 2, what?
Minus 2 square root.
Minus 2 square root of 3. I had somebody the other day ask me, well, you're supposed to use the opposite sign here? If you use the opposite sign there, it's not squared, is it? A quantity squared is a quantity times itself. Exactly times itself. So that's what I need to write. Let me make some room here at the top of the problem. And guess what we're going to have to do here? Start off with first times first. What's first times first?
10.
5 times 5? would be 25 square root of 4. Or if you want to take a shortcut, you can say times 2, but don't say square root of 2. Okay? Now that's the first times first. Then we'll do the outer times outer. Outer times outer, we'll take 5 times negative 2, which is negative 10, square root of 6. The inner times inner, which is another negative 10, square root of 6. Okay? Negative 10, negative 5 times 2, negative 2 times 5 is negative 10. And then the square root of 3 times the square root of 2, the square root numbers inside stay inside. Remember that. And now what's left?
Plus.
Last times last. A negative 2 times a negative 2 would be plus 4 square root of 9. Okay? 4 square root of 9. Okay. Times the square root of 4.
25
That'd
times
be
2.
25 times 2. And then what? These two combined together.
Minus 20 radical x.
That'll be minus 20 radical 6. Okay? Minus 10 radical 6 minus 10 radical 6 is a total of minus 20 radical 6. And then plus 4 times 3. Now, by the way, what is 25 times 2? Let's go ahead and do that out. 50. And, I can't simplify this. There will be some in the next few problems where you have to simplify the middle term. So watch out for that. Watch out for that in number 98. And number 97, actually. Number 97, you'll have to simplify the middle term after you get the answer. So if your answer doesn't check exactly, watch out for simplifying that middle term. But this doesn't simplify, so we just write down minus 20 square root of 6, and then plus, how much? 12?
12.
Is there anything else we can do to simplify that? How about 50 plus 12? 50 plus 12 would be 60, and then you still have minus 20 square root of 6.
I think 50 plus 12 is 62.
62? I was just checking to see if you were paying attention there.
You almost made it.
Almost made it. Okay. What you see is what you get, by the way. We don't do much editing around here. We just throw it out there and hope it's right. And okay. So now, the next thing I want to ask is, can I combine 62 minus 20? Can I go 62 minus 20?
No.
No. If it had been 62 square root of 6 minus 20 square root of 6, in other words, if they were both the square root of 6, then that would give you 42 square root of 6, because you're combining like terms. But with this one, the 62 is like a single number, and it's like this 20 is married to the square root of 6. And this 62 is trying to get somewhere with this 20, and the 20 says, no way, I'm married to this square root of 6. And there's no combining unlike terms, right? So it has to stay like that. So the final answer is 62 minus 20 square root of 6. Okay, any questions on that? Okay, that's all for today. That's all for this section, and have a great weekend.